Welcome to your session this morning, well, afternoon almost. Today, myself and my colleague Alex Ross will be talking to you about monitoring Tableau Server for success. There's a bit of an interesting story about this presentation, just to kick things off. We actually originally were assigned to talk about just one of the many tools that we'll take you through today. And we kind of took a step back and went, this would be useful from one perspective, but actually the way that we see this in the field, so just to give a bit of a blurb, Alex in particular has seen probably some of the largest and widest Tableau servers available out there on the market, has helped customers guide them through their Tableau server journeys. We said actually this session would be much better positioned if we can kind of reflectively talk about what those customers are actually doing. As you may be able to tell by the session title and the jackets that we're wearing today, we are massive Back to the Future fans, so we'll subtly kind of put this into today's session. We also couldn't decide which one of us should be the doctor, so we've decided that a coin toss meant that both of us should do it. That and Alex didn't want to wear a red gilet for the session. So it wouldn't be a Tableau conference if we didn't start with a dashboard. There's, again, to start with an interesting story, the middle is almost today's time. I think I'm out by about 10 minutes. The one at the top is actually Tableau's founding date. So this is the first time Tableau came into being as a company, as a registered company. And the one on the bottom is the first ever release of Tableau Server. So about 4 years into the company's journey, almost 11 years ago now, we've gone through a few iterations to get to this point. So why might you be in this session today? I'm not going to make you take a moment to think that, but you should all roughly be server admins and thinking about how to best position your Tableau server for your users. But the way we're looking at this today is we're going to take you through how you can look at Tableau Server from the past perspective. So forensically looking back in terms of what's happened, what are the changes, what did users do at particular points in time. We'll bring you forward into the present and say how can you monitor what's actually happening in your Tableau Server instances right now, or as close as we can get. And then we'll take a look into the future and just see how can you anticipate growth or projects that are onboarding. What are the things that you can do to kind of identify how your Tableau server will perform? And if you get all of these right, then you'll be the master of your own universe. So more on the why. There are other drivers that might kind of lie behind all of these things. The first of which we kind of narrowed down to 3 in terms of what we're seeing right now in terms of why a customer might want to look at Tableau Server a bit more in depth. And the first of those comes from this new role-based offering that you've probably heard quite a lot about over the past few days. And this gives you complete architectural freedom from the perspective of managing your server. So all of a sudden with this unrestricted freedom, you want to get it nailed on in terms of how you set up the architecture that lies behind your Tableau server. Secondly, you may start to notice or may get a hunch that your server is actually hitting that point of capacity. So we're going to show you how customers that we've worked with actually identify that they're near capacity, how they can account for the fact, and steps that they can remediate to actually go from there. And the last point, if you're just trying to juice out as much performance that you possibly can from your Tableau server, get the right match of processes for your use case, then what are the things that you can do to optimize for that? So as part of today's agenda, we're going to go chronologically. Oh, wrong button. And we're going to start in the past. So we're going to look at tools like the logs, things like Logshark or Postgres. We've also dropped in Tableau Prep as a neat little bonus. We'll then take a journey into the present with Tabmon. We'll also look at some third-party potential offerings like Splunk and Snowflake, and then move into the future and look at TabJolt. So I'm going to go rev up the DeLorean, and in the meantime I'll pass on to Alex, who's going to start in the past with Postgres.
Thank you, Tom. So, just like in the Back to the Future films, we're going to start by jumping into the past. I'm not going to take you as far back as 1955, but I do often get asked by customers, how can they understand what users have already done on their Tableau server? So they might ask questions like, who's been logging into the server? Who's been viewing the most content on the server? Or how long are my extracts taking to refresh on the server? And there's already some really rich information available to you in the underlying Postgres repository for Tableau server that you can tap into. And whenever I get asked this question, I always encourage my customers to start by looking at what we ship out of the box and making best use of that. So to that point, Tableau server comes with inbuilt administrative views that give you powerful monitoring of how you can analyze and understand your user behavior on Tableau server. They're designed to help you monitor different types of activity. And as I said, they're provided out of the box, so this is just part of the product that you get. On the right-hand side of this slide, you can see a comprehensive list of all of the types of administrative views that we ship. So it gives you information on traffic to views, traffic to data sources, recent users, extracts. We'll have a look at some of these in just a sec. If you don't know how you find them, it's really simple. So you just click on the status tab on the navigation bar at the top of Tableau server, and you will need to be a server administrator or a site administrator to get access to these views, hence kind of in the name, admin views. If you are a server level or a server administrator, you get analysis or a view of what's happening across your entire Tableau server. Whereas if you are a site admin, you'll only get individual site views so that you can understand what's happening within your particular site. So let's just take a look at a couple of examples of these quickly. First example is showing us traffic to views. So here it's giving us information in the top left, such as sorry, I can't see. Yeah, the views per day, so we can see a trend over time. What's the traffic looking like over time? Are there particular bottlenecks or points, days of the week, or over the last month where people have been hitting the server more often? Below that, you can see it on an hourly basis. So are there times of day where the server is busier? Is everyone coming in at 9 o'clock in the morning, looking at that Tableau dashboard and then getting on with their day? And at the bottom, the bar charts are showing me the most popular content and the most popular users in terms of the views that they're accessing on the server. Another example here is giving me some information about the types of activity that people are taking. So this is giving us an insight into what people are doing on the server. Are they logging in? Are they publishing data sources? Are they downloading workbooks? And again, that trend over time gets me some insight into the peaks and troughs as to when these things are happening. Now, the example here isn't that much activity because this is my personal Tableau server. You'll see a big spike, for example, where I think I had 117 logins on one day. That was me just running a script in the background of the server. You can also see that I've got 7 subscriptions running, so every day I'm receiving 7 subscriptions from my personal Tableau server. And then the third example I wanted to share with you is about backgrounder information. Now, hopefully your Tableau server doesn't look like mine. This is showing me that all of my extracts are currently failing to refresh. But if you do have any extracts that are failing to refresh, what's quite nice is that this view gives you the next level of detail as to why that extract might have failed. So not only how long did it take to run, but what was the error message that came back? Was it because Tableau couldn't connect to the underlying data source? Maybe symptomatic of a network problem. Or perhaps it was to do with the credentials that were being used to connect to that data source having expired. So it gives you a really good insight into the extractor, the extract processes, the backgrounder that's doing that. And if you are finding that you have a very busy backgrounder, this is actually a really good starting point to look at any extract jobs that might be running in the background, consuming resources, but not finishing, because they're taking out resources on your server, but ultimately they're not leading to anything fruitful. So these are just 3 examples of the standard admin views that we provide out of the box in Tableau. But sometimes that doesn't answer the question you have. You want to take it a little bit further. and you want to know more than what the out-of-the-box views give you. So examples of this that I've heard from customers I've worked with were one customer who wanted to know which of their users have been running tab command scripts on their Tableau server. Another one wanted to know which IP addresses their users were coming from, so they could start to do some kind of geographical analysis of their user community and where people were connecting to Tableau server from. And this is where you want to look at start building your own custom admin views. And you can do this by hooking Tableau itself into the underlying Postgres repository using the read-only user that we make available to you. We also provide, on the right-hand side here, this is a screenshot of the online help. We give you comprehensive documentation that describes the schema of all of the tables and views that exist in Postgres. So if you want to understand which table you want to go to get various bits of information, have a look at the online help, and that should really start you off in the right direction. Now, just as a little bonus, one of the things I sometimes get asked when customers are building these custom admin views is regarding how long Tableau retains this information. And the answer to that question is actually, first of all, it's configurable. So as a Tableau server administrator, you can actually change settings on Tableau server that defines how long it's going to keep this data. But there are kind of three key areas that we retain. So one is around the history tables. This provides you information like the events that have been going on the Tableau server. And those history tables, by default, will keep information for 6 months. Another area is the HTTP request tables. And this gives you insight into the gateway process on Tableau server. So it's kind of HTTP traffic that's happening over the network. And by default, that gets kept by 7 days because it gets wiped when you do a cleanup or a backup process. And then the third one I'll mention is backgrounded tasks. So if you want to look at the view we just saw a minute ago to get insight into your backgrounded task and extracts, by default, that stuff is kept for 30 days. So let me just show you a couple of examples here of a custom admin view. One more thing on this, actually. There's loads of good examples in the community of custom admin views. So if you're not using them already, just go onto the Tableau forums. There's loads of examples that people have shared of Tableau workbooks that you can just download and get you started that way. The example we're looking at here on the screen is actually a custom admin view that our consultants at Tableau use when we're doing Tableau server health checks on behalf of our customers. So we have this workbook, we hook it into our customer's Tableau server Postgres repository, and it spits out something that looks like this. So the page we're looking at now is a good summary view of a customer's Tableau server. All the data has been anonymized here. But it's giving me that summary information about how many sites, projects, workbooks are there on the server, how many users do we have, and then the line charts at the bottom are giving us trends over time to show potential growth on that server. So if there are more users coming on board or more hits on my server over time, I'm getting a really good insight and overview as to what's happening on my Tableau server. And then one other sheet I'll show you on this same workbook that we use gives us more detailed usage analytics. So I won't go through all the different views here, but my favorite one is actually the one in the bottom left, the scatter plot with the red dots. And what this is showing us is it's really highlighting any poor performing content on my Tableau server. So it's showing me, for example, the percentage of my workbooks that are taking longer than 60 seconds to load. So this is a really good opportunity to better understand what is that content that's taking so long to load on the server, and maybe reaching out to the owner of that content to see if you can help them optimize it. One of the axes as well, by the way, is the number of hits. So what we're looking at is there anything that's going really slowly that is also very popular? Because that's the low-hanging fruit that you want to try and optimize to not only give your users a better experience, but also make sure that Tableau is going to perform better because potentially these workbooks are taking a lot of resources on the Tableau server.
And just a quick point on this one in the bottom left as well. So a customer I worked with recently used this particular view itself to actually drive or to identify the impact of additional capacity on their server. So for example, if we actually look at this bottom set here, there's something that's really interesting, which is almost 30% of these workbooks in this view take longer than 20 seconds to load. Now immediately that asks us the question of, well, why are these so slow? 20% or 30%, that's a big chunk of slow loading workbooks. Is it poorly designed content? Do users need to be educated better in designing content? Or do they potentially need to look at the effect of VizQL processes? Or maybe we should just have more capacity on this server to run the throughput quicker. So they were able to test that with additional capacity and reduce the kind of scope between these performance buckets. Really good use of it.
Thanks, Tom. Oh, back to the presentation. Cool. So with that, I'm going to hand over to Tom, who's going to talk now about how you can take your analysis even further by not only looking at the Postgres repository, but starting to look at the Tableau server log files.
Bless you. How many people in this room currently use log files as a way of monitoring their Tableau server instance? Glad you do, Tima. So logs are incredibly powerful. They're incredibly valuable in terms of the richness of information that you can gather within them. So there's George McFly there holding dearly onto his Tableau server logs. Just a brief bit about logs for those of you that haven't looked at them in depth from a Tableau server perspective. They're actually kept in JSON format. So they're JSON format within a text file. You can generate them using the command line or the Tableau server view. But one of the best things of the power that once you get comfortable with these Tableau server log files, it gives you is it can kind of preempt problems before involving Tableau support. So actually our own support team always use the log files to identify problems. But if you can start understanding them, getting familiar with them, it gives you that heads up for a better response rate. Further still, the log files for Tableau Desktop, Tableau Server, and Tableau Prep are all in fairly similar formats. So once you've seen one, you can typically read and understand what the others are doing. And I accidentally said the bit on command line before. But where can you find them? There are two sets of Tableau Server log files. The first is the communication logs. Now all the processes in Tableau Server, they've got their names there. And you can actually see that they match up to the processes on Tableau Server. And if you haven't got familiar with Tableau Server processes yet, you can actually find where these match up to within our help documentation as well. You can typically find these in the Tableau Server data, Tableau Server log files. And don't worry about remembering this and see a few screenshots. This content's actually going to be shared with after the presentation if you want to save space on your phones. I know there are a few photos taken at last night's party. So the other set is the C++ logs. So the communication logs all the traffic between processes, between users logging onto the server. The C++ logs just takes a record of all the heavy lifting, all the queries, all the really interesting, rich information that happens within certain processes. And again, these can be found in a slightly different location in terms of Tableau Server data, TabServe, VizQL Server logs. So I'm not quite sure why they're in slightly different locations. Maybe trying to hide them for some reason. But the first of the logs I'm just going to introduce you to is the Apache logs. So if you're looking at trying to identify potential authentication issues or just what people are trying to do when they're accessing your server, or if you're looking at embedding content, the Apache logs are a great place to start to just take a look at what's happening as users enter or try and access Tableau Server. The structure of them is fairly standard. They all look like this. So on the left-hand side, you can see the IP of the request, the time it happened, the port it used, the actual request itself, as well as the status of that request, followed by the size in bytes, the time in microseconds, not 100 or 1,132 actual seconds, and the actual ID of the request itself. To give you a quick example, here are a few log entries from my own Tableau server. And something you might notice is the request response coming back is actually an unauthorized request. So if you're trying to see unauthorized accesses to your server, you can actually identify that in your log files. Now I'm not too concerned about these unauthorized requests because on this far left-hand side you'll see that there's no actual requesting IP address. That's because it was me on my own local Tableau server forgetting my password multiple times. So I'm not too concerned about this. The next set of logs are also in these C++ logs, and these are probably in my mind, the most valuable set of logs that you can actually analyze. If you're trying to identify long-running queries on your Tableau server, you can actually go to specific k-values within these log files and break down the information that you're actually trying to extract out of it. So one of those k-values is something called end query. Now we can see here that the end query structure is always in this format typically, and we can see the actual query that was sent, so it logs all the queries, the time it took to run that, and even the number of columns that this query ran across. So a great way to identify slow-running queries as well as complex queries that are on your Tableau server instance. Another k-value is something called end update worksheet. So very similar format again, and we can see the JSON structure to these logs. But this time what it's doing is saying, what was the specific view within a dashboard? How long did that take to load in total? So if you're trying to identify these long loading workbooks on your server, then a great place to find that information quickly. With these points as well, because the logs are in JSON format, there's nothing actually stopping you from connecting Tableau Desktop directly to a smaller log file using the JSON data connector and just importing these files and filtering on these k-values. Now, possibly the most valuable k-value that I've managed to identify, at least from my perspective, is something called QP batch summary. So a bit of background into the QP batch summary. Whenever a user navigates to a dashboard or a view, what Tableau Server will actually do is I compile all the queries and identify which ones are the most complex, or at least try and identify which ones are the most complex. It'll then order them from the most complex down to the most simple, and then run those in that order. What this means is when this happens, that following that order, if any of the more simple queries can use some of the cache results from the earlier queries, or just use some of the similar format, then fusion or caching can occur. The great thing about QP batch summary is it actually tells you whether or not the cache was hit or fusion happened. Something to point out within QP batch summary as well, if you do start digging around in this information and try and draw it out yourselves, is you'll notice there's an elapsed as well as an elapsed sum. Now, elapsed sum is the total processing time it took to run each one of these queries. So you'll notice some of them would have run in parallel, not all of them would have happened sequentially. So that elapsed sum is the total processing time it took to run these queries. But this elapsed time is the amount of time the user would have experienced that load time. So a great way to look at both sides of this perspective from a load side. So what are some tools that you can use to actually start digging into these log files yourself and start extracting some of this useful information? The first of these is Logshark. So Logshark is a community managed tool. It originally came from Tableau, and we've put it up on GitHub. And it's a nice, easy way to start processing your log files. So again, completely available on GitHub. You can start using it as soon as you like. Why might you use Logshark? Well, first of all, again, mentioned it's easy. Once you've installed it, you can start ingesting your log files through the command line and actually just upload them on a regular basis, have that past snapshot of what's happened through those log files, and you get an understanding of your Tableau server instance. It actually uses a NoSQL store behind the scenes as well, so it can actually just be an efficient way to store your own log files. The great thing as well is as part of the Logshark process, once it stores these log files, it runs a set of batch ETL tools on the top of that to turn it into a Tableau-friendly structure. So when it comes to analyzing the results, it's in a way that Tableau expects to see files in that more relational format, so it's easy to start asking questions of the resultant data. And lastly, because of that, you can also aggregate the log files as well. Oh, and also our support team use it. So a great way of saying, I've seen this in Logshark, can you tell me what that means? And they'll understand what you're actually talking about. So what does the output of Logshark look like? It's a great story behind this. This is actually our own Tableau server instance, our own Tableau server cluster. We call it Alpo internally. Immediately, you can see all 6 nodes of this Tableau server instance. This is the SRM counters, so just looking at the amount of resource, in this case CPU, used. And it's not incredibly granular. It's more of a snapshot at the point of time. So I wouldn't use this to be an exact measure of the CPU used at this point in time, but it's a great way of seeing trends. So if we look at this very briefly, we can see that across, this is actually just a single day of our Tableau server, you can see that there are a few spikes to 100%, more CPU utilization in the 3 nodes at the bottom, which we'll find out more about later, but nothing too concerning right now. You can actually use it to find VizQL server errors. It's a great way to just pick out things where there could be bad content or just some things that look a bit odd. So if you start seeing trends of errors increasing, then there may be something wrong with the server instance as a whole. There could be something wrong from a network configuration. All of these things you can start identifying and questioning from your own server perspective. This is one of my favorite views. It actually looks at request performance per hour. So you can actually set the thresholds. I can't reach that high, so I'm going to point into the top corner. I can jump, but not that high. You can actually set a threshold of what is good for you and what you're actually trying to look at. So if we're looking at bootstrap session times now, anything that I'm saying loads longer than 10 seconds is bad in my world. So now I can see the proportion of those requests and the proportion of bad load times. Again, this is great because not everybody sees bad in the same way. Everyone has a different performance threshold, so great to customize that. So we could see here on the far right, we can see that actually it looks like our performance degrades as we hit February the 10th. I believe February the 10th was actually a weekend, but even still, if we look in the bottom, we can see, again, nothing to be concerned about. It's just something happened in the later hours on the server when it's not really being used, so I'm not too concerned. The last one's actually new to Logshark, and this looks at Hyper queries to actually record all the queries that Hyper's sending. The great thing is it actually shows you the split of those requests. So if we look at the worker nodes in this top left-hand side now, many of you haven't heard much about our internal instance before, but just by seeing this, I can tell that 3 of those nodes are VizQL processing nodes, so that's data engine right there in the orange. And then here, this is an insert, lots of insert processes, so they're dedicated backgrounder nodes on our internal service. And you can tell that just by looking at these charts. Now, we're not restricted to just using the provided tools that are out there. You can actually parse these log files in any way that you see fit. And the one way I decided that would be a great way to actually parse these log files is using Tableau Prep. So I'm going to run over here. Stand far away from this microphone. So there's something I've neatly called Lumber Flume. What Lumber Flume is a way of just using Tableau Prep to parse out your log files. So what I've done is I've ingested all those VizQL log files that I said I was interested in seeing before. In fact, in this particular flow, I've just set my K values I'm interested in seeing are end update sheet and end query. And then if I show the changes here, you can see all it is just parsing out those text files into individual columns. Nothing overtly complex. It's just this is the easiest way to do this in Prep right now. But the best thing about using Prep is before I even start analyzing these log files further in Tableau Desktop, I can immediately start asking questions of this data as well. So if I select Quick Filter here, I can actually see all the rows that were related to queries sent by Quick Filter usage. And then even still, you saw it on the keynote before, with proportional brushing, I could see where those quick filters relate to. So actually, none of my dashboards, because I make sure I use dashboard best practices, never use quick filters. But it does relate to less than 1% of the no workbook views, which means this was a web edit type feature. Wrong one. Ah, there we go. So the output of running something like this, so you're not restricted to using Tableau Prep. You can parse in any way you see fit. So a colleague of ours used Visual Basic. I don't suggest using Visual Basic. Prep is faster. I've also created something called Lumber Snake, following the theme, using Python as well. There will be a blog post on this at some point as soon as Tableau Conference and all the madness goes away. But the output of this file can look something, pardon me, a little bit like this. So this is running through an example of what a customer has, and we can see every single query that was sent as part of their Tableau server instance. So lots and lots of queries here. And immediately we can spot outliers that were taking considerably long to actually run. But what's probably the most important bit here is we can actually break those queries down into the type of queries that were sent across this week. So we can see plenty of cache hits, plenty of abstract cache hits. Only a small percentage didn't hit cache. But actually, possibly the most important thing here is about 49% of their queries, almost half of their queries, were sent as a result of quick filters. So something I can feed back immediately off the top of this is maybe we should look at dashboard best practicing, user education. I have a feeling that especially some of these longer loading, quick filter type things up here are probably where we've just got tons and tons of quick filter options, of long lists of results, and it's just taking too long to process them. So just by reducing that number and using more interactivity in dashboard design, we could probably increase your Tableau server performance without changing anything else. So we're going to stick our logs on top of the Tableau DeLorean. They're very valuable. I'm taking them with us. But they're incredibly detailed and useful. You should be using them. You should be looking into them. And as they're JSON, you can ingest them in any way you see fit, or parse in Tableau Prep or anything else. Or you can look at existing tools like Logshark to actually do all of that work and the ETL processing for you. Now, one more thing before we move away from logs in particular and we move it into the present is, as we mentioned, logs are in JSON format. This is really useful. What this means is that we can actually ingest them into NoSQL stores, so Splunk or Snowflake. You can just feed them into these NoSQL stores. And then the great thing is Tableau Desktop has connection options to both Splunk and Snowflake and others. So you can actually start ingesting them in as often and as frequently as you like, and then stick Tableau Desktop on the top of that and report on the top of that. So you can have an almost near real-time, or as often as you want, view on your Tableau server performance.
Tom, I just wanted to share a couple of large-scale deployments who are doing exactly this. So the first is a customer who's using Splunk, not only to ingest the Tableau server logs, but they combine that with Windows perfmon data and Windows events data. So they have the CPU, the RAM, the kind of application logs all in one place for them to analyze. And one of the use cases they then do is they start to do behavioral analysis of how people are using the server. So are they doing things like web editing? What quick filters are they clicking on? And what order are these users doing those things in? And another good example is our Tableau Online SaaS solution, where we use Splunk, but actually we found it a little bit cumbersome to deal with the volumes of data. Bear in mind that Tableau Online is being used by over 4,500 sites, I think we have to date. So it's really, really at scale. So what we chose to do is we took the Splunk logs and we built a simple ETL to push those into Snowflake. Snowflake are downstairs if you've not seen them, but they've got a really good kind of database as a platform service in the cloud. And once we have the kind of Tableau server log files appended to these tables in Snowflake, we then publish that as a data source to our internal Tableau server environment so that our Tableau Online team can analyze the performance of the Tableau Online platform by getting this kind of really detailed view of the log files across all of our customers who are using Tableau Online.
Thanks, Alex. So now we're getting back in our car, we're going straight into the present, and the first thing we're going to look at from a present day perspective is Tabmon. So Tabmon's a bit like Logshark. It originated from Tableau. It's been pushed out into the community, and now it's community supported. You can actually get Tabmon on GitHub, again, available to download for free, to use, to tweak as much as you like. And if you're interested and want to contribute to it further, again, push things to GitHub. It's a very open community, a very willing community to get involved with. So Tabmon's a great way of actually recording all of these health and system metrics just straight out of the box using something that's provided from a Tableau perspective. The results that are produced, like everything else we've seen, can be analyzed in Tableau Desktop, or you can put it onto Tableau Server and look at it from a more frequent perspective. And again, just like everything else, you can look at troubleshooting, historical performance, or actually look at a more present-day perspective because these are ingested more frequently. Now, Tabmon looks a little bit like this. So this is an example of a 3-node cluster. And something just to point out is you can see each of the different systems there, the different nodes, and how they're performing, again, from a CPU utilization this time, over time. Something I briefly mentioned before is there's a spike to almost 100% there. Now that's not overtly concerning. I'd probably be more interested in long-term trends rather than just a single spike. These can happen all the time. And then we're looking at queue lengths as well, and again, nothing particularly worth looking at of interest in that just there. But some of the key things you can actually use or monitor using Tabmon is things like request latency, so the time it actually takes for a process to start rather than the total time of it processing. Things like success rate, the number of active sessions, and I just want to point out this is the number of VizQL sessions that are open. So a user could go to a Tableau server dashboard, click on something, and they have an open VizQL session, but they then may swap browsers and start looking at Facebook and whatever, Twitter or Instagram. But their VizQL session hasn't ended yet. It's still open. So it's not quite concurrency, just the number of open VizQL sessions. You can also look at overall machine counters as well as cache hit ratios. You can almost think of Tabmon as the Fitbit for your Tableau server, but other health tracking watches are available. Now to show an example of where you could use this, again, using that same 3-node cluster, we can see we've got our different Tableau service processes split out in colors here. And something that immediately points out to me is I've highlighted here what I would assume are peak hours, so between 8 a.m. and 7 p.m. At least that's how long Alex makes me work. And if I confirm this against my usage stats also in Tabmon, I can see that actually that's pretty much correct. I can see there's a huge spike of users coming on at 8 a.m. and then that filters off between 4 and onwards. I'm assuming that this is a European server and just the time is 1 hour ahead. But if I go back here, something that almost gives me cause for concern is the actual backgrounder usage across all 3 nodes at all times, basically. So what that tells me is that actually this hasn't been configured to best support this the usage of this server. Because actually we kind of see it with this final spike. There's a huge spike, and it's because there was a high number of VizQL sessions that used 25% of the processor time, but still lots of backgrounder usage on the same node at the same time. And because there's backgrounder use across all 3 nodes, that tells me there's no dedicated backgrounder instance here. It's just probably a standard set of processes across all 3. So you can use things like that to say, well, actually, this clashing set of resources means that I should reconfigure my processes and try and isolate the things that are being used the most. So if worker 3 was turned into a dedicated backgrounder node instead, then this frees up worker 2 and 1 to just run VizQL node or VizQL processes. Some key tips and tricks for using TabMon. There are actually no strict targets. I'm not going to say that this is the exact number that you should look out across any of these thresholds. But if we looked at things like machine utilization, those spikes are completely normal. They're going to spike and drop off, and that's fine. But if you see things like an 80% consistent use of CPU utilization, that's possibly more concerning. That's telling me that you're edging towards capacity, and there could be potential risks further down the line. You can actually, because this is open source, it's on GitHub, you can actually expand the list of counters that you use with Tabmon. So one of my particular favorites is something called sessions in flight. So I mentioned before we could look at open sessions, which is when VizQL sessions are open and could be open for however long. Sessions in flight actually shows the number of active VizQL sessions at any given time. So what this means is if there are multiple users, we'll just say 10 right now, all clicking on different dashboards, all interacting and just looking at things, then they would be logged as a session in flight. So this is a very close measure you can get to identifying the number of concurrent users on your server. We're going to go even further past the current day. We're going to leap into the future, and I'm going to hand back over to Alex.
Thanks, Tom. Doctor Who and Back to the Future on the same slide. You don't see that very often. So before jumping into the future, I just want to highlight one key point about Tabmon, if you compare it with the other tools we've looked at so far, and that is that it gives you kind of real-time picture of what's going on your server. So unlike looking at log files or looking at Postgres, which give you a good snapshot of what's happened historically, Tabmon is a really good way of looking at what's happening now. And the other nice thing that I like about Tabmon is that if you are running a distributed install, it gives you a single picture of the processes across everything in your cluster rather than an individual server. So if you are using third-party hardware monitoring tool, that can be really good to look at a specific server, but it can be difficult sometimes to get the complete picture as to what's happening across your Tableau server cluster. Okay, so it's time to go into the future. And the key tool which is going to help you plan the right capacity for your future use of Tableau server is TabJolt. And it does this by simulating load against Tableau server using your content in your environment. So for those of you that haven't heard of TabJolt already, it's a point-and-run load performance testing tool that's specifically designed to work easily with Tableau server. Unlike other load testing tools, it automatically drives load against the server without you needing to develop something or write scripts for yourself. And as with Logshark and Tabmon, it's also available on GitHub. So we've open sourced this. You can download it from GitHub. You can contribute to the project on GitHub as well. And this is what the architecture of TabJolt looks like. Too many tabs, get myself confused. So you run TabJolt on its own machine, separate to your Tableau server environment. It's powered by something called Apache JMeter, which is a Java application designed to do exactly this, load test functional behavior and measure the performance you get back from it. When you do a TabJolt test, the results are written to its own Postgres database, which means it's really easy to then analyze the results of that TabJolt test using Tableau Desktop. And as I said earlier, the way that it simulates load is it actually sends requests to the Tableau server gateway, and it effectively emulates what a user would be doing when they're either viewing or interacting with a view on your Tableau server. Now, one of the things to think carefully about with TabJolt is what are the valid uses, what are the use cases for when it's appropriate to use TabJolt. So as part of the customer solutions team, Tom and I often are working with our customers to recommend the right hardware for them. Maybe you don't believe us, right? So maybe you want to validate this for yourself. You want to make sure that what Tableau is telling you is the right hardware is actually correct. Right? So this is a really good use case for running TabJolt. It lets you do it in your own environment, on your own content, to meet your own goals in terms of the number of users that you need to support to run Tableau efficiently. Another good use case is for go-live testing. Doc Brown used Einstein, his dog. Tableau used TabJolt. Right, so maybe you've set up your Tableau server, you're ready to launch and go live with Tableau, but before you do that, you want to make absolutely certain that your production environment is going to withstand the load that is going to be placed on it after you go live. So through using TabJolt, you can run tests, you can give yourself confidence that Tableau server is going to scale and perform to meet the anticipated load that's going to happen after you go live with it. Another good use case is around server configuration. So many of you, if not all of you, probably know that you can distribute the processes of Tableau server differently to optimize performance. So you can put different processes on each of the nodes in your cluster. And maybe you want to test the impact of doing this. Yeah, so for example, in Tom's Tabmon use case that he was showing, maybe that customer wants to know what is the impact if we do choose to isolate our backgrounder onto its own node. How is that going to affect the users and the response times that those users are seeing on Tableau? Another example might be if you want to tinker with the number of VizQL processes. What happens if we increase or decrease the number of VizQL processes on each node? How is that going to impact the overall performance? So TabJolt allows you to run tests with different process configurations so that you can make sure that you're running the best process configuration for your environment. One thing to bear in mind if you're using it for this is that TabJolt only simulates the viewers and the interactors. So it's not doing anything with the backgrounder process. So just bear that in mind, because the backgrounder and the extracts that are refreshing and the subscriptions that are going on, those happen in addition to anything that you might be testing with TabJolt. If you're running on virtual environments, which most of our customers are these days, you might also want to tinker with the virtual machine settings. What happens if you allocate your resources differently to Tableau server? What happens if you try and pull those resources with other applications? How's that going to impact Tableau? So you can tinker with your VM settings and use TabJolt to see what the impact of doing that is. If your Tableau server is growing, you might know that you're going to have more content on Tableau. You're going to be onboarding more users on Tableau. You want to know kind of what the breaking point is. Right? So at what point are we going to have so many users or so much load on the server that we actually need to think about scaling out and adding more hardware to the cluster that we have for Tableau server? And then finally, upgrades. If you're upgrading, we release new versions every quarter. You might want to test that there's not going to be any degradation in the performance that your users are seeing after you go to the later release of Tableau. Of course, working for Tableau, we'd say the answer is always that it's going to get better. We're continuously improving performance, but you might want to validate that for yourselves. So there are a few golden rules for running TabJolt tests. There's actually quite a few. I've tried to pick some of the key ones. The first is that your workload should be real world. So really think about how are your users interacting with the server today? What types of users do we have? So that the load that you're putting on your TabJolt tests is representative of how your user community are using your Tableau server environment. Don't test with a single workbook. This is quite easy if you're an existing, if you're already live with Tableau and you've got lots of content, that's really easy to do. Sometimes where I see this as more of a challenge is organizations who are just about to launch Tableau server for the first time. They don't have lots of content, so they just build one workbook and they hammer that with TabJolt. It's not representative of how your users are going to use Tableau server. Think about the right mix of interactors and viewers. So one of the things that TabJolt will allow you to do is to define how many or what percentage of your user community are simply viewing a dashboard and then going away, versus how many are actually interacting. They're not just viewing it, they're then clicking on filters or changing parameters or clicking on actions that you've built into the dashboards. And those different types of users will put very different load on the Tableau server. Know the number of concurrent users that you need to support. Right? So what's the point in running a TabJolt test if you don't know what the goal is? Right? If you know that the goal is to try and support 100 concurrent users or 200 concurrent users, TabJolt's great at trying to prove to you that it's going to scale to meet that need. But if you simply don't know, all TabJolt's going to do is going to give you a number and say, right, based on this hardware, here's the number of concurrent users that Tableau server is going to support. But is that a good thing or a bad thing? We don't know. So definitely have your goals set out up front. The other thing that I sometimes see my customers do is focus a little bit too heavily on response times. So sometimes what I hear from the business users is our goal is to make sure that the dashboard responds in less than 2 seconds. And that's great as a goal, but actually what typically affects that the most is the design of the dashboard. So TabJolt isn't testing how efficient that design of the dashboard is. What it's testing is how many users can look at that dashboard before there starts to be a degradation in performance. So not only look at the response rates, but look at the other KPIs that TabJolt monitors. One of those is called the TPS, the throughput per second. So how many kind of transactions can be done per second. Another is the error rate. So as you reach saturation point on Tableau, you will start to see errors. That's natural. Right? Tableau is very robust. It won't fall over, but it will start to give errors as you reach saturation and use up all of the hardware that's available to it. Run tests for a while. If you just run a test for 60 seconds, there's just too much going on to get enough data to give you a valid analysis. So run your test for at least 10 minutes, if not more. As I said, expect errors. As you reach that saturation point, you will see some error messages. That's normal. And if you don't remember anything on this slide, the last point is probably the most valuable. Add think time. So what think time is in TabJolt is it's a pause between interactions or views. So think about how your users use Tableau in the real world. They're not continuously hammering F5 or the refresh button on the dashboard. They actually load the dashboard, they look at it for a few seconds to interpret what's going on, and then they click on a filter to do the next thing, to filter and look at it a different way, or click on an action to drill down into the data for more information. So think time allows you to simulate that pause and make sure that that's built into the test. Otherwise, with zero think time, TabJolt is literally hammering Tableau server as hard as it possibly can. The other nice thing about TabJolt is it allows you to create customized test plans. So the example we're looking at on the screen here is one that I put together that ramps up to 200 users. So the goal here was to try and test for up to 200 concurrent users, or threads, as TabJolt uses to simulate concurrent users. It uses a 50-50 mix of interactors and viewers. And one thing hopefully you can see on the slide here is at each step of the plan, it ramps very slightly. So rather than having a vertical step up to the next step of the plan, I'm actually introducing an additional 20 users every time over a 60-second period. So rather than just saying, I'm just going to add 20 users at exactly instantaneously the same moment in time, I'm just kind of gradually adding those over 60 seconds, holding it for 10 minutes, adding another 20 over 60 seconds, holding it for 10 minutes, to see at what point we start to see a degradation in performance. But again, TabJolt allows you to create your own customized plans to meet your or simulate your load as closely as possible. Now, I'm not going to run it here. It doesn't demo particularly well. But when you do run it, it's just a command line tool. There's a few flags you pass, like the duration of the test, the number of concurrent users, and the name of the plan to output. And this is what it looks like when you run. It just kind of iterates through and prints to screen as it's going, how many threads are running, if there's any error messages that are coming back. But probably what's most valuable is the output you get, which is this Postgres repository with the results of your test and the Tableau workbook that hooks into that. So let me show you an example of how I've used TabJolt. So this was about a year ago now. If I can just get to the right slide here. All right, Viz, sorry. This was me playing around with different cloud platforms. I got a bit carried away, to be honest, but the goal here was I was really interested to understand how the biggest public cloud platforms, AWS, Azure, and Google Cloud Compute, compared to each other for a given kind of 8-core machine. Now, for those of you who are using the cloud, you'll know there's lots of different virtual machine types or instances that you can spin up, and they all cost different amounts of money. So I've just highlighted 3 different instances that I ran a test against. What we're looking at here, first of all, is the AWS R4 4x large instance type. This is an 8-core machine. And it's important to just highlight what these trends that we're seeing, these lines actually mean. So the one at the bottom is showing us over time, so over this 60-minute test, it's showing us the number of threads or concurrent users which we're stepping up over that 60-minute period. So I'm gradually adding more and more users onto the Tableau server. The third one down is the error rates. So lower is better, obviously. We don't want to see errors. So if you see any kind of spikes going up, that's where something's happening that's causing some errors on Tableau. The second one down is the test per minute, or the kind of transaction rates per minute. So this is how many things are going on the server, how many tests are we doing per minute. And then the top one is the response time. So again, lower is better. The faster our dashboards are coming back, the better. So this is the blue line is the AWS machine we're looking at here. And as you can see, if we look at the top line, for example, we get to a certain point around 50 minutes where the average response time just starts going up. Like we've just reached saturation at that point. You can also see that it drops, the test per minute to kind of drop off a cliff a little bit because Tableau will start to recycle processes in the background to keep things going. So the server's still going, but it's just really struggling to keep up with the load that's being put on it at that point in time. Let me just click on the others to compare. So the next machine that I've highlighted here is in Microsoft Azure. This is an H8. It's like one of their high memory, I think, machine types. And yeah, very similar performance, but probably my average response times start going up a little bit more quickly if we compare that to the AWS machine. Also, if we look at the error rates, there's like some huge spikes here, which we weren't seeing in the previous test. And then finally, this is what GCP looks like. So GCP, again, very similar performance, a bit more spiky in terms of the response times that we were seeing when we reached that saturation point. Okay, so let me just summarize everything that we've talked about in our session today. Tom and I will be staying around afterwards. We kind of run out of time for questions, but we will stay around afterwards. Come and see us if you do have any questions about the content. So we've shown you a bunch of ways today of how to look at the past, the present, and the future when it comes to managing and monitoring your Tableau server deployment. In terms of the past, we showed you how you can use Postgres to get an understanding of what users have done in Tableau server already, and this should really be your starting point for monitoring server. For those of you who are more curious, have a look at the log files if you're not doing so already. That's going to give you that next level of detail, and you can use tools like Logshark or Tableau Prep or other third-party things to do that. In terms of looking at what's going on currently, Tabmon is the best tool that Tableau offer to help you answer that question. But again, you can use third-party tools to ingest our log files or do clever stuff to give you that kind of real-time picture of what's going on. And when planning for future capacity, TabJolt is your friend, and it's going to provide you with the confidence that Tableau will scale to meet the needs of your organization as your Tableau server deployment grows. So just take a second to think about one of these tools that we've talked about today that you could see yourself using. I'd really encourage you, when you get back to work tomorrow or on Monday, to really think about how can you plan to install that and start using it to better monitor your Tableau server environment and provide a better service, better performance to your Tableau server users. So with that, Tom and I are going to jump off in our DeLorean, but we will hang around for questions before we do that. Please, can you fill out the feedback? This helps us to make these sessions even better every year. So if you go into the TC18 app, go to our session, there should be a link there to provide us with some feedback. But thank you very much, everyone, for your time. Much appreciated.
Thank you.